Jai Hind everyone. Today I am going to discuss the new topic of the red-black tree. In this particular, we are going to discuss specifically the insertion operation. So, after today's lecture, you will be able to understand what is red-black tree and various associated operations. And we can also analyze the time complexity of these operations. Okay? So, first of all, what is red-black tree? Red-black tree is a self-balancing binary search tree. We have already learned binary search tree in data structures. So, whatever is the property of binary search tree, that is the parent node lies between the left node and child node, right child node. Similar way, red-black tree also follows the property of binary search tree along with the color node. So, in red-black tree, we have an extra bit for denoting the color of the node, and that is either red or black. That is why it is known as red-black tree. Now, what are the various properties associated with the red-black tree? Some properties are red-black property. That is, every node is colored either red or black. Means whatever node we are inserting or creating in a tree is either red in color or black in color. Next, root property. The root node of the tree is always black in color. Next is the leaf property. Every leaf is black. Every leaf, that is nil. Nil means whatever we are having the leaf nodes do not have any child, and such nodes are termed as nil nodes, and all are black in color. Next, we have red property. If a red node has children, then children are always black. Means red parent cannot have red child. Red parent can have only black child. Next, depth property. For each node, the height, or you can say the number of black nodes till the leaf are equal in number. Means all the black nodes are having same numbers. That is, for each node, any simple path from this node to any of its descendant leaf has the same black depth. Means if I am drawing a tree like this and I am saying this is black, this is black, this is red, and this is black. So from wherever path I calculate the number of nodes, black nodes are equal in number. That is, if I take this, consider this path, how many black nodes are there? 2. If I consider this path, how many black nodes are there? 2. If I consider this path, again I have 2, that is nil node. So, this is your red-black tree. See, root is black in color and red parent, this is red parent and it has black child. Okay, and all these null nodes, that is beyond leaf, are black in color. So whatever null nodes we are having in the red-black tree are black in color. And along with this red and black property, this particular tree is following the property of binary search tree. You can check for any node. Here we have 4, left child is 3 which is less than 4 and right child is 8 which is greater than 4. If I consider 6, left child is 5 which is less than 6 and right child is 7 which is greater than 6. So, along with the BST property, it add on the color node. Now, root node, as we know that every root node, the root in the red-black tree is black in color and 2 adjacent nodes cannot be red in color. Okay? Means if I am drawing a tree like this, these are 2 adjacent nodes. So, these 2 nodes cannot be a red in color. One node must be in black. every path in the tree must have the same amount of black colored node. That is, we have already discussed the property. If I am considering any of the path of the RB tree, then in that particular case, the number of black nodes are equal while following any of the path. Next, how red-black trees maintain the self-balancing properties. As we discussed in the very first slide in the definition of RB tree, that RB tree is nothing but it is a self-balancing binary search tree. So, the limitations put on the node colors ensures that any simple path from the root to leaf is not more than twice as long as any other such path. It helps in maintaining the self-balancing property of the red-black tree. Now, what are the basic operations associated with RB tree? That is insertion, deletion and search. So, today we are going to discuss insertion. So, for insertion operation, as in the binary search tree, insertion can be done on the basis of only one property. That is, we have to consider this property that parent must be less than equal to right child and parent is greater than is equals to left child. But in RB tree, one color condition is also there. So, for that, some situation arises and basically we have two cases. So, insertion operation follows the same insertion algorithm for binary search tree, plus the elements are inserted following the binary search property only. That is this property. Additionally, the nodes are colored either red or black to balance the tree according to the various properties which we discussed earlier. So, there are two cases. Case 1 is whether the tree is empty. If suppose I am inserting a new node in an empty tree, in that case only one single node will be inserted and this node will become the root of the tree, and root of the red-black tree is always black in color. So, the color of the node will become black only. But case 2, if the tree is not empty, if suppose a tree exists like this, A1, A2, and I have to insert a new node A4, A1, A2, A3 is existing tree and I have to insert A4. In that particular case, the new node which I want to insert must be red in color. And this new node will be inserted to this tree as per the BST property. After comparing each and every node, we will follow the BST rule and then add this new node to the tree. After that, we will face two different situations. That is, tree is either balanced or not. Maybe all the properties of red-black tree are fulfilling accurately, or it may be a case that any one or more than one properties of red-black tree are violating. So, as per the violation of properties, we will decide the case either by performing rotation or by recoloring the node. So, if the parent of the new node is black, then there is no issue. We can simply add that node and just exit. For example, if I am having a node this 10, existing tree, this is black in color, and I want to add new node 15. So, what is going to be the color? Red. So, as per the BST property, this 15 is going to be inserted to the right of 10. So, color of this 10 is black and color of this 15 is red. So, no issue is there. No property of RB tree is violating here. So, we will just stop here. So, this is the first case, that is the parent of new node is black then exit the operation, left the tree as it is. There is no change in the tree. But if the color of the parent is red, in that particular case, we will apply some rotations. For example, now this is the existing tree. 10 is black in color, 15 is red in color. Now I want to insert 25. So 25 is the new node. Now it is going to be the red in color. Now what is its correct place? Correct place is right of 15. So 25 is inserted and its color is red. Now you can see that red parent is having red child, which is not allowed in arbitrary. Arbitrary property says red parent can only have black child. Red parent cannot have red child. It means there is a violation of red-black property. So in this particular case, we will rotate the tree. RR rotation is applied here, and after that recoloring will be performed. So how recoloring and rotation is done? If the parent of new node is red, as in this example, and the color of the parent sibling is either black or if it does not exist, you can see parent is red in color and sibling of parent is black. Sibling is what? The node which is here. If there is no sibling, it means also that it is black in color, and if the sibling is existing and it is black in color, then also apply a suitable rotation and recolor accordingly. Rotation after applying the rotation, we will recolor the nodes. But if the parent of new node is red and color of the parent sibling is also red, means whatever node is present here is also red in color. In that particular case, recolor the parent and the sibling and grandparent nodes to black. We only have to recolor the parent node, sibling node and grandparent node to black. But if grandparent is root node, in that particular case, grandparent is not recolored. We will only recolor the grandparent node if it is not the root node. Now, let us learn how to draw a red-black tree by following various properties. So, here I am going to take this particular example. So, first of all, I am having an empty tree. There is no node existing. There is empty tree. So, first node is going to be inserted in the empty tree. So, now this one will become as the root node. So, its color will be black. Now, second node is 2. As per the BST property, we will insert this 2 to the right of 1 here, and its color will be red as per the red-black tree property, because whenever we insert a new node, it must be red in color. Next, we have 3. Again 3 is going to be inserted to the right of 2 and its color is red. Now see, property has been violated. Red parent is having red child, which is not allowed. So what we will do? We will either perform rotation and recoloring or recoloring based upon the case which we discussed in the previous slide. So now check the color of sibling of the parent node. This is parent node. Check its color. Its color is black, as it is a nil node and nil node is always black in color. So sibling of the parent node is black in color. In that particular case, we have to apply rotation. Now, which rotation is applicable here? It is right-right rotation. So, after applying right-right rotation, what we will get? We will get a tree like this. Okay. So, now this is going to be the tree. and after applying the rotation, we will recolor. So now its color is black, this is red, and so now we are having tree like this. Next node which we have to insert is 4. So when we are going to insert 4, how 4 is inserted? We will compare 4 with this 2. 4 is greater than 2. We will go to the right subtree. Here 3 is there. 4 is compared with 3, which means 4 will be inserted to the right of 3 like this. New node is red in color. Now again check. Parent node is red in color and child node is also red in color. It is violating the property. So for this, again we will rotate and recolor as per the case applied. So first of all, check the sibling of parent. Here check, sibling of parent is red in color. So what we have to do, we do not have to perform any kind of rotation. We just have to recolor the parent, grandparent and sibling. Okay. So parent is red, recolor it to black. Sibling is red, recolor it to black. Grandparent is black, but grandparent is root also. So there was a special case that if grandparent is root, in that particular case, we do not change the color of grandparent. So your tree will become like this. Grandparent color is not changed at all. Sibling is black in color. Parent is black in color and new inserted node is red in color. Next, we have to insert node 5. So correct place for 5 is greater than 2, right subtree. 5 is greater than 3, right subtree. 5 is greater than 4, right subtree. That is to the right of 4. Here we have 5, which is red in color. Now again see, red parent is having red child. Property is violated. So what we have to do? We again have to check the case. Check the case. 4 is the parent and its sibling is black. When parent sibling color is black or does not exist, in that particular case, we have to apply rotation and recolor. So what we will have to perform? Rotation. So on this portion, again RR rotation has been applied. So after applying RR rotation, what we will get? We will get this 4, 3 and 5 and recolor it. So 4 will become black, 3 will become red. Okay? The color of these two nodes, that is parent and grandparent, will be interchanged. Now this is the tree. Next, what we have to perform? We have to insert 6. So when we insert 6, correct position for 6 is right to the 2, right to the 4 and right to the 5. So here 6 is going to be inserted red in color. Now check. 6 is red, that is child node, its parent is also red. So again property violation is there. But sibling of parent is also red. So what we have to do? We only have to recolor parent, sibling and grandparent. Not the rotation is applied. So parent will be converted to black in color. Sibling will also be converted to black and grandparent to the red, like this. So we will get a tree like this. Next, last node, we have to insert 7. What is the correct position to insert 7? That is to the right of 6. So when we will insert 7 to the right of 6, what we will get? We will get a tree like this. And see here also property violation is there. So when property is violated, again check the sibling color. Parent sibling is black in color as it is nil node. So when this is nil, it is black in color. So what we will do? We will apply rotation. So rotation is applied on this portion of the tree, RR rotation, and recoloring, or you can say color changing of parent and grandparent are interchanged. So finally we will get a tree like this. So in this way we are going to create a red black tree. Now you can check all the properties of red black tree. Here root node is what? Black in color. Now check any path, total number of black nodes. If I consider this path 1, how many black nodes are there? Only 1. If I check this path 2, how many nodes are there? Black nodes? Only 1, that is 3. This. If I consider this third path, black nodes are 1, that is 6. If I consider this fourth path, number of black nodes are 1. So whenever I calculate the black height of the tree, it is always same from the root to any leaf node. Next, red parent is having black child. Black can have any, either red or black. There is no constant with black node. But red parent can have only black child. So all properties are satisfied. It means tree has been drawn correctly. I hope the topic is clear to you. Thank you. And these are the references.